Hey everyone, welcome back. This is episode 3 of our series on Synadia Agents. Last time, we checked out the client and agent SDKs and used some example code to spin up an agent and a little REPL to chat with it, all running over NATS. Today, we're going back into the repo to look at some of the stuff we didn't get to. First up, I'll show you what a DSPy agent looks like when you build one from scratch with the Agent SDK. Then we'll check out a setup that will let us spin up multiple headless agents. Finally, we'll dig into more of what the client SDK can do, using a dashboard that acts like a meta agent, coordinating a bunch of independent agent harnesses at once. Lots of cool stuff to get through, so let's dive in. So yeah, last video, we had some examples as a starting point, but honestly pretty minimal. The repo has a ton of more fleshed out examples that go way further, so let's check some of those out. Let's check out these examples. So under the examples directory, we're going to check out this DSPy folder. And this is an example of building a fully functional AI agent using Synadia's TypeScript SDKs. This example is built around 3 ideas worth knowing before we dive in. The first is DSPy. Normally, when you're building with LLMs, whether it's a simple classifier, a RAG pipeline, or a full agent, you end up writing a lot of raw prompt strings. You're carefully wording instructions, tweaking them every time the model changes, and manually chaining outputs from one step into the next. It's brittle. DSPy replaces that with structured composable code. You define what you want, the inputs, the outputs, the logic, and DSPy handles generating and optimizing the prompts for you. It works across all of those use cases: single LLM calls, multi-step pipelines, and agents. The second is the React loop. React stands for reasoning and acting. It's a pattern where the model doesn't just answer the question, it thinks through a problem, picks a tool to call, observes what comes back, then reasons again based on what that result is. It keeps cycling through that loop until it arrives at a final answer. It's what makes an agent feel like it's actually working through something rather than just responding. The third is Ax-LLM, sometimes called Ax. It's essentially DSPy for TypeScript. You define type signatures, inputs, and outputs, and Ax compiles those into the actual prompts and agent logic. It handles React out of the box and works across a bunch of different LLM providers, so you're not locked into one. This example pulls all 3 of those together to build a working Synadia agent. The agent registers as a service over NATS, takes prompts, uses the Ax-powered React loop to work through tasks with 4 sandbox tools: listing files, reading files, writing files, and running bash commands. As it works, it streams back live updates so you can see every tool call as it happens, followed by the final response. So we're going to build the SDKs, drop in our NVIDIA API key, and any client in the repo or our own can start talking to it. So let's check it out. Let's just go over the code very quickly. We're going to start on index.ts, which is the main file. And if we look at the code, it doesn't look too much different than what we've been working with. We set a bunch of constants, and then one other thing we do here is create a sandbox directory to work in. So I've already made this directory and pre-allocated some files to work with. Here I'm instantiating an API to be able to talk to the LLM. And for this, we're going to use an OpenAI model. And then, as you've seen before, we're going to instantiate our agent service. And below, we have our onPrompt function. And inside, you'll see we have a function to set up our tools that our agent uses. And you can see here we pass our sandbox directory into the function. So let's go ahead and check those out real quick. So our tools are under this tools file here. And here's that function. And you can see the way these tools are set up. They're basically descriptions of each tool and a provided helper function. We have list files, read files, bash, etc. We also have a helper file to get this running. We have this run shell script. This script sources the environment variables, checks that the NVIDIA API key is set, kills any previous instances, and then executes bun run source on our index file. And before we run this, we just make sure that both of our SDKs are already built. Now there's one other file in here I want to go over, and that's this ask.ts file. It's basically a client that connects to our agent. You can see here we use agents.discover, and we prompt it with this preloaded question. list the sandbox contents, and summarize what you find. So let's run it and see what happens. So I have NATS server already running, and let's start up the agent. So I just ran that run script, and now let's run that ask script, see what happens. List the sandbox contents and summarize what you find. There we go. And you can see it's listing every step as a status. The sandbox contains two files, and it lets me know what it found there and summarizes everything up. And it used its provided tools to do that. Let's prompt it with a NATS request, just for fun. And the usual, yo, who are you? And we were using an OpenAI SDK, so it makes sense that this responds that it's ChatGPT. So this all lines up. So yeah, that was a pretty cool example of using Ax-LLM and building an agent from scratch. But let's check out another example. We're going to show off our Pi headless example, and it's a little more interesting because it uses a controller and allows you to spin up multiple agents. So let's check that out. Before we jump into the Pi headless code and run it, let's just quickly see how it fits together. Pi runs in your terminal. You point it at a directory and it reads files, runs commands, writes code. But it lives in one process. If you want to drive it from a browser, another machine, or several places at once, there's no built-in way. Pi headless is the bridge. When it starts, it puts a controller on the NATS bus with three verbs: spawn, stop, and list. You call spawn with a working directory, and it fires up a new Pi session and registers that session as its own separate agent on the bus. Ask NATS what agents are available, and you see the controller plus every session you've ever spawned, each with its own working directory, model, and conversation memory. One process, many agents. The flow is simple. Send spawn, get back subjects for your new session, publish to its prompt subject, and stream the response back. Each session handles one prompt at a time, so prompts to the same session queue up and run in order, while different sessions run independently. Stop is just another call to the controller. In the background, expired sessions get swept off the bus and everything publishes heartbeats, so clients can tell what's alive. So let's check out this Pi headless example. Over here under examples and Pi headless. So this project is different from our Pi plugin. It wraps Pi in a NATS transport, so any other program anywhere on the network can spawn sessions, prompt them, and stop them. So the cool part about this is when we spawn a session, it doesn't just expose a single agent on the bus. When it starts, it puts a controller on the bus. The controller has three verbs: spawn, stop, and list. You call spawn with a working directory, and the controller fires up a brand new Pi session pointed at that directory, and then it registers that session as its own separate agent on the bus. So if you ask NATS what agents are available, you don't see one Pi headless thing. You see the controller, plus every session you've ever spawned. Each one with its own working directory, its own model, its own conversation memory, its own subjects for prompting and status, and heartbeats. So here's how to quick start this. You're going to pass in your NATS context, and you can just run npx just like this. You can also install it locally and call it directly. And if you install it, again, you're going to follow these directions. You're going to want to build both SDKs. And there's a little demo CLI command here you can run. And there's also some optional defaults you can pass in if you want to. And now here are the subject endpoints that you can hit to run those controller commands. You can see here we have agent spawn, agent stop, and agents list, amongst the others. There's also an example spawn CLI request that you can see. You can see here some example code of the client SDK, and notice now we're searching by the session ID for the agent. We also have some CLI helpers here that you can run for some examples, as well as some important notes to check out. So you can see here that the fourth subject token is a session ID for the agent, and that's what we used above in the example client code. There's also a metadata marker for the controller to tell the difference between the controller and all the agents it spawned. Now before we run this, let's just look over the code really quick and get familiar with it. We're just going to do a quick run through of the code, and it really comes down to 4 different files. So this all starts in this main index file, and this sets up a few things for us. First, in our main function, we're setting up a Pi session manager. So let's take a look at that real quick. So this thing does what it sounds like. And this thing is pure state and lifecycle. This is what manages each individual agent. It keeps tabs on all of them. And it responds to our controller, which we instantiate back in the main function. So let's go back. All right, back where we left off, here's the controller. We instantiate it here. Let's look at it. The controller registers as a protocol compliant agent, and it's the always on entry point. This is what exposes the entry points for spawning, stopping, and listing agents. So essentially, this guy takes your requests and then forwards them off to the manager. And then the manager does the lifecycle. And then finally, manage session, which is the agent itself. And this should look familiar, so let's take a look. And this is where you're going to see reference agent. If you recall, we went over that a little bit in our last video. So again, this should look pretty familiar to you. This is where we instantiate our agent service using reference agent. So this represents each individual agent that's spawned by the controller. And then we have the functions that the agent service uses, like handle prompt. So let's run it and see what it looks like. Because I'm using Py, I'm going to use my Py. So let's start the Headless program, and this will start my session manager and my controller and all that. And there you can see it started. Let's just double check. It's just a microservice. And there it is, confirmed. So let's hit that controller and spawn an agent. We'll just make our request. Boom. Let's list our services again so we can see it. Cool. There it is. And you can also see we started it in the temp Py sandbox directory. So let's prompt it. And for this, we're going to have to grab its session ID. And I'll just add it in here. All right, it's cooking. Let's see what happens. Sweet, there's our response. Let's just check it. I know it's chunky, but we can see here it says the current directory is temp Py sandbox. Let's spin up another agent and prompt that one. And there we go. We created this one on a different directory. And you can see here in the Py that it also shows that we spawned those two agents. But for fun, let's list them over here again. All right. And there, again, we can confirm that we started these from two separate directories. So let's prompt this one. And we're going to need its session ID. Put it there, and let's see what happens. And there we go. That one is also responding. Let's just scroll up and see what it said, because it said a lot more. And it looks like it's going to list all the files in this directory. This directory had a lot more in it, which makes sense because we didn't create a new directory this time. We use our existing temp directory. All right, so that was a little messy looking, but now I want to show you something really cool. All right, the last thing I want to show you. The Agent Web UI example. This is what happens when you apply the Client SDK with a UI. And it's a dashboard for interacting with any number of agents running on your NATS context. It's built with Vue 3 on the front end and a Bun server on the back end, connected by a single WebSocket. The Bun server exists because the TypeScript SDK can't run in a browser. It owns the NATS connection and bridges everything to the UI. When you open it, you see a unified grid of cards representing every discovered agent, controller, and active session grouped by type. Clicking a card will open a context-aware panel. For a regular agent or session, you get a live chat surface where you can send prompts, attach files, and watch responses stream in. With a controller, you'll have another panel that'll allow you to spawn off new agents. There's also the ability to fan out prompts, so you can message 3 different agents with the same prompt. And agents are automatically discovered. So the layout is you have your browser communicating over WebSockets to your server, which speaks NATS to your agents. Now it's really easy to run this. Again, you just make sure you have both SDKs built. So there's 2 options to run this. You can run in dev mode or production mode. And there's a couple of bun commands to get you running here. It's pretty straightforward. It also supports running some optional flags or environment variables if you need to do that. So there's some information here on the fan out pattern with spawning sessions as well as midstream queries. But don't worry, you'll see that in a second when we run it. And there's a quick setup here that you can do to verify that this is working. But again, we're going to run it ourselves and spin all these agents up. So in some ways, we've kind of set up a meta agent, an agent that can speak to and interact with multiple agents all in one dashboard. Now let's see it in action. So I have my terminal on the left and the dashboard on the right. And what we're going to do is start up some agents and watch them appear on the dashboard. The dashboard is using the NATS WebSockets library to communicate. So we're going to start up Claude Code. This is going to be using our agent plugins. We went over this in our first video. So I'm already set up and ready to go. And if you see here, I just started a Claude Code agent. The dashboard picked it up. You can see I start from the Synadia Agents directory, and it even shows the owner and the prompt subject there. And when you see the green dot blink, that's actually a heartbeat. Let's start another agent. Let's start our Hermes gateway. And it's up, and there it is. And for fun, let's start Pi. Again, it's already configured. I just started up, and it should show up. Cool. All right, so let's prompt them. I'm going to prompt Claude Code first. So let's select it and type something. I'll go with the standard, who are you? And we can see Claude Code doing its thing, and we should get a response soon. All right, what did it say? I'm Claude Code, Anthropic CLI, running as Opus 7 on the repo on Peter's machine. And that's accurate. So we have two other agents running. Let's try that fan out pattern and see how that works. So just for clarity, I cleared the terminal. Now this time, I'm going to send the same message to the Hermes and the Pi agents. I'm selecting to stream all the output into a virtual session that combines both of them. And again, I ask, who goes there? Hello, I am an expert coding assistant here to assist with various tasks. So Pi's trying to be a little sneaky, but we can clearly see it's Pi here. And Hermes was a little more honest. Hermes agent created by new research. Let's see if we can get a better answer out of Pi. And the fan out pattern worked again. We get two messages back. And this time, Pi says I'm a collaboration between OpenAI's GPT model and NeuroNetwork's Pi coding platform. Very cool. I truly hope that's how you pronounce that. Now, these are using our plugins. These are all agent harnesses that we're wrapping. But remember, with Pi Headless, we were able to spawn up multiple agents with a controller. And guess what? We can do that right here. So I actually have my Pi running right now. Let's start up that service. So in a second, we should see a controller container pop up. And there it is. And now let's spawn an agent with it. So we have some configuration here. I'm going to create it in the temp directory again on my Pi, and we'll use GPT-4. Let's spawn. Now this agent actually has a lifetime, and you can see all the information for it right here. Let's give it a prompt. And I'll bet you can predict what we're going to ask it. The old state your name. And it's telling us it's an AI developed by OpenAI. And that checks out. Let's not waste any resources and kill this agent off. And that just uses the same controller commands that we were using earlier. Everything's very easy and very elegant. So yeah, this was a quick demonstration on what's possible when you mix the client SDK with the UI, communicating with various agents. It's still a work in progress, but I think you can see a meta agent actually forming here. Now there's one final thing I want to go over really quick before we call it. The last thing I want to touch on in the repo is this useful using NATS CLI markdown file. We're not going to do a deep dive, but there's a lot of very useful stuff here. It basically tells you how to use the CLI in various ways to interact with the agents. Gives you some inside knowledge on the spec and what the protocol looks like. And then it even covers some gotchas at the end. Just little things that could hang you up. It's worth checking out. And that's a wrap on episode 3. We built a DSPy agent from scratch, spun up multiple headless agents, and explored the client SDK through that meta agent dashboard. Next time, we'll keep pushing deeper into what these tools can do. If you got something out of this, Drop a like and hit subscribe so you don't miss the rest of the series. Thanks for watching, and I'll catch you in the next one.